is Jill Emerson. I'm the Water Quality Coordinator at Green Mountain Conservation Group and the Project Manager for the Rivers Program from Saco River Corridor Commission. And today we're going to go over the Rivers sampling protocol. So Rivers is our citizen science water quality monitoring program that runs bi-weekly between May and October. Citizen scientists participate all throughout the Saco watershed at specific sites that Saco River Corridor Commission and Green Mountain Conservation Group have identified. And so today what we're going to do is we're going to walk you through not only the equipment that you have to use for the monitoring, but the correct protocol to monitor the sites based on our CLOP. So first of all, I'd like to thank you for being part of the program. This program is only successful because of your contributions and your time. And we could not run this program without you, so thank you very much for being one of our volunteers. Your equipment that you get is your responsibility throughout the entire time that you are doing your monitoring. This is roughly about $5,000 worth of equipment, so we're going to show you how to take the best care of it, everything from calibration through proper cleaning and packaging the equipment back up. If you are unfamiliar with the Rivers program, there is a YouTube video that explains all about what Rivers is, what parameters we're collecting, and what type of volunteers we are looking for. That's available on the Green Mountain Conservation Group YouTube channel. So if you haven't already checked that out, please do so. If you have and you are somewhat familiar with the program, what we're going to do now is jump into the actual training. So first off, when you get to your site, the first thing you want to do is make sure that there is nothing there that would jeopardize your safety. During the duration of the program, your safety is our #1 concern. We don't want people to go out monitoring if there is a threat of local flooding, if there is a lightning storm happening, or if you see suspicious people or persons at your site. Again, equipment can be replaced, sampling is nice, but your safety is our utmost concern. Most likely the threats that you will have out in the wilderness will be poison ivy, ticks, and unstable footing. So we highly recommend that you take a few minutes at your sampling site to just observe what's around you, make sure you didn't put your bag in a pile of poison ivy. I have done that. It's terrible when it happens. Please, at the end of your sampling, check yourself for ticks. They start early in the year. It's April, but we've already had them. And again, just be safe while you're out there sampling. When you go out to sample your site, your equipment bag will contain a variety of components that we're going to go over today. Your equipment bag will have a Hawk meter. You will be given 2 probes, one for dissolved oxygen and a second probe for conductivity. You will be given a thermometer. You will be given a spectrophotometer or turbidity meter, complete with sampling vials, oil, and a felt piece of fabric. Your kit will also include bottles specific for your site that will be pre-labeled with your site's designation and what sample you are collecting. And you will be given a binder containing calibration logs, quick guides on how to do the monitoring, and your data sheets will also be located in here. Your equipment bag will also contain a first aid kit, bare aspirin, and if you are a GMCG member, you will also get a snack if you need a snack. Your equipment bag will also contain extra batteries in case any of the equipment runs out while you're out monitoring, and you will be given appropriate labeling equipment as well. If you are the first volunteer in the morning monitoring a site, you will need to calibrate the equipment for dissolved oxygen. However, even if you're not the first person calibrating, we still want all of our volunteers to know how to calibrate the equipment should something happen during monitoring, like if the calibration accidentally wipes, or if you've noticed the person ahead of you has not calibrated appropriately. So in your bag, there's also a small calibration kit that contains a bottle of deionized water for calibration. You will get an Erlenmeyer flask and some special Kim wipes. Now, The way that to calibrate your equipment is you turn on the Hawk meter by hitting the power button. It will do its Hawk promotional logo and then the screen will come up. To connect a probe, you will want to insert the pins correctly into the top of the meter. Now, it doesn't matter which side you plug which probe into, but what is important is that there is a small black notch here that only fits one way into the instrument. So if you're finding it doesn't quite fit, please do not jam it together because you will damage the equipment. Just rotate it slightly until you feel it click into place. Once connected, you can screw the lug nut tighter to hold the probe into place. Then you should receive a prompt on your screen telling you that a calibration is needed. The DO calibration holds for about 8 hours, so this is why it's important for our volunteer every morning to make sure that the DO probe has been calibrated. To calibrate, you will take off the protective cap on the DO probe. This unscrews, like so. And now you will want to be very careful to try to minimize contact with this DO cap. Once this gets scratched, it kind of loses the ability to calibrate appropriately, so we want to make sure that this is protected as much as possible. We're then going to take a small bit of our DI water, and we're just going to rinse our probe. So here I have a collection container. You can do this over your kitchen sink. You can even do this outside if you'd like. Once we've rinsed, we're going to gently dry with our Kim Wipe cloths until there's no water left on the probe. This is very important because if there's water left on the end of the probe, calibration is not going to work. Next, I'm going to take my Erlenmeyer flask and I want to just aerate as much as possible by shaking it vigorously for about 30 seconds. So you're not sitting there watching me do this for 30 seconds. We're going to cut it a little bit short. Then we'll open the cap. You'll place your probe inside so that it's not touching the water, but instead it's hovering above the water. Now what I do is I'm going to hit the green read button, and I'm going to get this status bar that comes across the front of the screen. Once the status bar is completely filled, calibration has been completed. Now, calibration can take anywhere from 30 seconds to 15 minutes, so it's really important that you allocate enough time to do your calibration and that you have a little bit of patience with it. A very important thing to keep in mind as you're doing this calibration is that it's easier and it works faster if all the equipment is the same temperature. So we highly recommend that you do this calibration first thing in the morning. You bring the equipment into your house and you just calibrate it right in your kitchen or in your living room. I tell my volunteers a lot of times, just when you wake up, start your calibration and then go ahead and have your cup of coffee, eat your breakfast, brush your teeth, whatever it is you normally do in the morning, and then just keep coming back and checking on it. Once you see the calibration hit 100%, you simply follow the prompts on the screen. So first we're going to hit the done button here, which then gives us the results of our calibration. And then most importantly, we want to hit the store button next. It may take a few seconds to register the next screen, so again, have some patience. Once your calibration has been done successfully, you should see an OK symbol in the upper left-hand portion of your screen. If you do not see this OK symbol, that means your calibration has not been stored correctly and you need to perform the calibration again. Your conductivity and turbidity meters should be calibrated for you before you go out into the field by qualified staff. If at any point in time, however, you notice a question mark in the upper left-hand portion of your screen showing that one of the meters has not been calibrated appropriately, please make a note of it on your data sheet and contact your appropriate organization. When you arrive at your site, we want you to park in a way that is not obstructing traffic. When you get to the river location that you're going to perform your sampling at, we want you to fill out this top section of your data sheet. That includes information like your name, the time that you began sampling, your site designation, and the time that you started. Second on your data sheet is we want you to tell us what the weather is like to your best approximation. Is it clear? Is it cloudy? Is it rainy? We also want you to take your best guess at the air temperature, the wind conditions, and whether or not you can remember if it had precipitated in the last 24 hours. The next section on your data sheet is site observations. This is where you will record information like what color is the water, if any. Do you notice any smell? What type of features do you notice at the bottom? Is the bottom of your river site rocky, sandy? Can you even observe the bottom? And how fast is the water flow? From there, if there's any additional site observations, perhaps you've noticed that there's new construction happening, road work, or maybe new wildlife activity, please feel free to write in the section at the bottom that has additional site observations. The back side of your data sheet is really where much of the information that we need for the program will go. The top section is where you will fill in the type of meter bag that you've used and whether or not that you see the calibrations have been stored in the machine. This again is denoted by having an OK symbol in the upper left-hand portion of your monitoring screen. Below that is where you will enter in the dissolved oxygen and conductivity information. Once you've filled out the front part of your sheet, what we want you to do is now get your probes into the water. These probes are going to need a few minutes to acclimate to their new aquatic environment, so please make sure that you're giving them ample time to get accustomed to the water. What we want you to do is we want you to find a section of the river at your site that is free of obstruction. So we don't want you to put your probes behind a rock or a fallen tree that may be there. And we want you to find some well-mixed water, which essentially means a place where that you can see the current moving at roughly about a foot per second. Now it's very hard to estimate what a foot per second is when you're out in the water. Basically, what we want you to do is make sure that you're finding moving water out there. So when setting your probes in the water, we want you to gently place your probes in as best as you are able to. What we really don't want to see is people winding up and hucking our probes out into the water. This can damage the equipment and we want to be as gentle with it as possible. So what I will do when I'm at the edge of the river is I will just slip them in, and it doesn't necessarily need to be at exactly the depth or the area in which you're going to be doing your monitoring. You just want to get it into the aquatic environment. You can rest these on the bottom. Some of you may have sites that have a heavy soil or murky composition at the bottom in which the probes could sink in. At those sites, when you actually begin to collect the data, we will ask that you hold your probes up and off of that murky bottom. However, if you have a very hard-packed bottom river location, hard-packed sand or rocks, you are free to leave your probes just resting on the bottom of the riverbed. Should you find yourself having to enter into the stream in order to collect your information, we highly recommend that you put the meter strap over your head just in case something happens. If you end up letting go of the meter or you slip, this will prevent the instrumentation from falling into the water. Much of the instrumentation is waterproof, so it is safe to take it out in the rain. However, we strongly urge you to not submerge the meter unit fully in water if you can help it. Obviously, if you slip and fall, that's understandable, but try to do the best that you can to not get this part of the machine fully submerged. So once my probes have been in the water for a few minutes, I want to now collect my data. First thing I want to do is make sure that I am seeing that OK symbol show up on the screen for both of the probes. Now again, you can plug in the conductivity and the dissolved oxygen probe in either order. It does not matter which probe goes into which slot at the top of the machine. The only thing that will change is the order of instruments appearing on your screen. So for example, whatever you plug in on the left-hand side will appear at the top of your screen, and whatever you plug in on the right-hand side will appear at the bottom. Once I have confirmed that I see those two OK symbols, I am now going to hit the green read button. Now I should see a status bar come up for both probes, and you may find that one probe takes a little bit longer than the other, and that's okay. Sometimes dissolved oxygen will click into place really fast and conductivity may take a while. Other times the opposite is true. Now, what you can actually see from the probes themselves is as DO probe is functioning, you will see a red and blue light flashing on the actual probe itself. This is normal and expected, so it's nothing to worry about. Once your parameters have registered, you will see a padlock lock into place. That essentially means that your data has been locked in and it is now safe to record your data. The instrumentation will also record the data for you automatically, so should you find that you are unable to access your data sheet, or alternatively you've forgotten to write down your data points, don't fret. Your data is stored in the machine and staff at Saco River Corridor Commission or at Green Mountain Conservation Group will be able to retrieve it. For each data point, you are going to collect 2 replicate samples. So from our meter here, I'm going to write down our first findings. So here we have a conductivity reading of 189.7. We have a dissolved oxygen reading of 4.99 milligrams. I'm also going to write down the percentage of dissolved oxygen located here. And finally, I'm going to take the temperature from the dissolved oxygen probe. Now, both probes do provide you with a temperature reading, but for official recording, we're going to take the dissolved oxygen probe. That being said, if for some reason you feel the temperature is off from your dissolved oxygen probe, please record the one from the conductivity probe. You will also be given a blue thermometer to put in at your site that can be used for comparison purposes. Once I've recorded my data, I'm going to hit the read button again and get my second set of parameters. Okay. Once you've recorded your 2 individual data sets, you want to verify that you have maintained your points within the maximum allowable differences. Maximum allowable differences for each parameter differ slightly. They can be located in your field manual or in the equipment bag. You want to just make sure that both of your values fall within the maximum allowable differences. For example, for turbidity, maximum allowable difference is 0.2. So when you take both of your readings, they need to be within 0.2 of each other. If they are not, you have to take an additional reading until you achieve that 0.2 maximum allowable difference. Should you find that after 3 or 4 attempts you are unable to achieve that maximum allowable difference, please write that in your data sheet to let staff at SRCC or GMCG know that maximum allowable differences were not obtained. Each sampling week, volunteers will be responsible for collecting a water sample for pH purposes. Additional weeks, volunteers may find that they have a second bottle to collect for total phosphorus, cation, anion processing, or other parameters. This is what your pH bottle will look like. You should have your site code on there and the date, along with what type of sample is being collected. Should you find that your site or your date do not line up to where you are, please make a note of it in your data sheet so that GMCG staff or SRCC staff can make note of it. When you enter the stream to collect your sample, you want to make sure that you are facing upstream of the river flow. So when I go into the water and I face upstream, I'm going to take my bottle, I'm going to loosen the cap so that it's nice and loose on top here, and I'm going to submerge completely into the water. I want to try to go at least an inch or 2 down if possible. I'm going to open the cap, allow my bottle to fill, close the cap, and bring it back up to the surface. From here, what I would do is then dump the contents behind me. This is called rinsing the bottle out. We want to get out anything that may be in this container from a sampler before, or maybe just something that was in the bag. So I'm going to discard this. And now the second sample is the one that we're going to keep. So we're going to do the same procedure again. I'm going to submerge, open underneath, close, and bring it back to the top. And I want to snap the cap into place. If you're finding it's difficult to snap the cap, you can let out a little bit of the water. Once my cap is snapped into place, I want to make sure that my label has been filled out with my initials and the time. You can do this before you grab the sample. It's actually a little bit easier to do this before the tape is wet, but it will still work after the tape is wet. Then I'm going to record the date and time on my datasheet and place the sample into the cooler provided by SRCC or GMCG. I haven't talked in weeks.
Yeah.
This is fun. Okay. For Green Mountain Conservation Group, every other week of the monitoring, you'll be provided with 1 or 2 250 ml bottles. There may be a time when you have to take replicates for your site. Your site supervisor, so either SRCC or GNCG, will let you know if it is your time to do a duplicate sampling. For Green Mountain, I will let you know when it is time to do your duplicates. So we want to make sure that the bottles, much like for pH, are labeled with the appropriate site that we are at and the date. If they are not, I want to make a note of that on my data sheet. The type of sample we are collecting, and then again, the time and the initials. So whenever I'm out there sampling, I want to fill out this label before I begin. To appropriately fill your sample bottles, whether you have 1 or 2, it's exactly the same procedure each time. So you want to unscrew the lid, and I like to rest it loosely on top. I'm going to face upstream of my river, and I want to submerge my bottle into well-mixed flowing water, at least an inch or 2 deep. I'm going to take the cap off and allow a little bit to go in. I'm going to place the cap back on top and bring it back to the surface. From here, what I'm going to do is I'm going to vigorously shake that water around in the bottle for about 10 or 15 seconds. And then I would discard this in behind me to allow it to go downstream. I would now do that 3 times, which I'm not going to do today, but I would do this rinsing step 3 times. And then on the 4th time, I'm going to collect a sample. This time I'm just going to let the bottle fill as much as I can. If you are in a place of low water flow, you may not be able to fill the bottle in its entirety, and that's okay. We just ask that you do the best that you can. I'm then going to cap it, bring it back to the surface, record the information on my data sheet, and then place the bottle in the cooler provided by SRCC or GNCG. For SRCC sampling, you guys are simply going to take your bottle, keep it closed, submerged in the water, at least 2 inches deep, open it up underwater, collect your sample, close the bottle, and bring it back to the surface. Then from there, you'll want to tighten the cap and put it in your appropriate cooler and mark the information on your data sheet. Please follow the labeling on the bottle that is provided for you based on the sample that you are collecting. So to collect for turbidity, you're going to use a very similar method as you did to collect your grab samples. These are the turbidity vials. You're provided with at least 4 in your case. What I'm going to do is when I enter into the river, I'm again going to face upstream. I'm going to loosen the cap, and I want to submerge it again into the water just like the other samples that we collected. Take the cap off and allow it to fill completely. Put the cap back on, bring it back to the surface. This first sample, again, I'm going to discard behind me. This is clearing the sample, the bottle, because we don't want anybody else's liquid that might be left over from a site before us to contaminate ours. I'm now going to collect the second, collect and keep this second fill. So I'm going to do the same procedure again. I want to be upstream. I'm going to open it up, collect, and then cap it. We want to make sure that we have filled up at least to the white line. I fill the vial up the entire way. And I'm just going to repeat with my second vial. You may collect more than 2 vials if you'd like, but you need to collect at least 2. From here, what I'm going to do is get out my turbidity meter. Make sure that it's on, and I want to make sure that I'm seeing the OK symbol in the upper left-hand portion of the screen. Once I see that, I'm going to dry my vial off, first with a paper towel. We want to try to get rid of any excess water that may be on this vial because we are going to put mineral oil on it. And as many of us know from when we were kids, water and oil don't mix. So once my vial is dried off, I am now going to take my mineral oil. And I want to put just a tiny bit of oil onto the glass. You don't need a lot here. This is not like putting ketchup on a hot dog. Then I'm going to take my velvet cloth and I'm going to spread that oil all across the glass as equally as I possibly can. This is doing a few things. We're getting rid of any fingerprints that may be on the glass, and the oil is filling in any scratches that may be on the glass from use. We want to try to get the best sample that we can that is of just the water and not have glass interference. Once I have spread my oil around, I want to just check quickly and make sure that I don't notice any major damages in the glass that may interfere with my sample. From here, I'm going to open the top, and I want to align this white arrow here on the glass with the black arrow here on the Hawk machine. You want to make sure that you push your cuvette all the way to the bottom until you can't push it in anymore. And then you want to push the cap down until you hear a click. Once you hear that click, now I'm going to hit the read button here. And again, much like with the meters that we use for conductivity and dissolved oxygen, I have this stabilizing bar going across. Now you will see numbers tick through as it's trying to zero in on the correct turbidity number. From here, I will record this number on my data sheet and then proceed to do the second sample. Okay. Once I have ensured that my two turbidity readings are within the maximum allowable difference of 0.2, I am now going to just discard this water back into the river. Our last step in the monitoring process is we want to write down what temperature we see on our blue thermometer. So what I like to do is when my probes go in the water initially, my DO, my conductivity probes, I like to put in this blue thermometer at the same time. By the time you've gone through all of the other sampling procedures, this blue thermometer will be ready to record. So all I will do at that point is I will look at the thermometer. This is based in Celsius, and then write down the number that I see on my data sheet. We use this as a reference check for our dissolved oxygen and our conductivity meters. It's also very important to not forget this piece of equipment at the river site. This is most likely the piece that you will leave behind. At the end of our sampling, we want to make sure that all of the information has been filled out on our data sheet. So before I leave any site, I like to check to make sure that all of the equipment has been packed up, that I don't see anything that I've left in the river, that all of the information has been filled out on my data sheet. We also want our volunteers to make sure that they are dropping their equipment off at the next location at the appropriate time. So sampling typically only takes about 15 minutes, but you may find that sampling on some days may take you a little bit longer. What's important to remember is to get the equipment to the next location on time, even if that means that you don't get to finish everything at your site. The most efficient way to sample is to put the probes in the water first, along with the blue thermometer, then collect all of your grab samples, work on your turbidity, and then collect your DO and conductivity at the very end, but you can complete the tasks in any order that you wish. If you are working with a partner, you may want to divide the tasks evenly between the 2 or 3 of you. We want to make sure that all of our sampling finishes up before 9 a.m. This allows us to control better for temperature changes that may happen during the day, particularly in the summer, and it also helps us capture the dissolved oxygen at its lowest value before photosynthesis starts to take place during the day. So equally important as it is to get your equipment to the next location on time, it is also important to remember that monitoring must be completed before 9 a.m. We hope you enjoyed this training video, and if you have any questions on how to do the monitoring, we strongly encourage you to review your training manual provided with you, or alternatively get in contact with either the Saco River Corridor Commission or Green Mountain Conservation Group staff. They're available to answer any questions that you may have during your sampling. Furthermore, we all try to get out the first week of sampling during the season to make sure that our volunteers feel comfortable with the protocol and the procedure.